Hi, it's Daniel from the Prisma team here. In this video, I'm going to show how to deploy a Prisma app to Vercel and set up connection pooling with PgBouncer. Using Prisma in serverless functions can be tricky. Databases usually have a limit on the number of open connections they can have. And with every function opening a connection to the database, your serverless functions will quickly exhaust the database connection limit, leading to failed requests. Additionally, opening a connection to a database is not cheap, and doing so upon every serverless invocation can significantly increase the latency of your API. These problems can be solved with PgBouncer, a connection pooler that sits between your application and Postgres and allows the application to open more connections than the database's limit. PgBouncer works by holding connections to the database and passing on a limited number of connections to the database and queuing additional connections for delivery when space becomes available. In doing so, PgBouncer prevents your serverless functions from exhausting the database's connection limit. Let's look at our agenda for today. The first step that we're going to do is we're going to explore the source code for the REST API and see how Prisma is used in the serverless functions. The second thing that we're going to do is we're going to create the database and the PgBouncer connection pool in DigitalOcean. Then we will create the database schema for the database that we created in DigitalOcean using our Prisma schema. And in the fourth step, we're going to actually deploy this REST API to Vercel and connect that to the database on DigitalOcean. Finally, in the last step of today's video, we will actually do a load test to see how our API performs when it's under load. Let's get started. So here I have the repository which we're going to deploy to Vercel. And let's take a look at the structure of this repository. So we have this API folder, and this is the convention when deploying to Vercel, that you have this API folder that contains the serverless functions. And so here I've defined a couple of serverless functions, but before we get into that, let's take a look at the Prisma schema. And so the Prisma schema will serve as the source of truth for our database. And as we can see here, we have three models defined. We have the user model, and that user model has a one-to-many relation with posts. So each user can have many posts, and then each of these posts can have many comments, as denoted by this comments relation field here. And then we have the comments model. And in addition to that, we also have this liked by. And this is a many-to-many relation between posts and users. And what this will allow is users to like multiple posts. So there we have it. And another thing to note here in this in the Prisma schema is that we have here this configuration for the database. And what will happen is Prisma will actually use this environment variable named database URL. So that was our Prisma schema. Now let's take a look at the endpoints which we've defined. So we have an index endpoint which will just serve a static reply to make sure that the functions have been successfully deployed. And then we have here a user endpoint, and this user endpoint will handle post requests and will use Prisma to create those users in the database. Similarly, we also have a feed endpoint which will get the 25 most recent posts and also include their author. We also have an endpoint for creating single posts and comments, and of course for a comment we need to pass the post ID. And finally, in order to like posts, and here we use this user update command in order to connect it to a post that it liked, and this will actually create the row in the many-to-many relation table. So those were our endpoints, and then there's one final thing to note here, and this is this Vercel.json file. So this file is actually telling these functions to be deployed to this LHR1 region, and this is the region that is in London. So you can see that here, and this will actually be deployed to AWS. So that was it in terms of the repository. The repository is ready to run and it has all of the dependencies. There's one final note to make here about that is specific to Vercel, and that is that in the package JSON, it's very important to have a post install hook that runs Prisma generate. And the reason for this is because when deploying to Vercel, Vercel caches the node modules folder. And because Prisma client actually relies on code generation, which goes into the node modules, it's important that that generate command runs after the node modules folder has been loaded from cache. So it's very important when you're deploying to Vercel to add this post install hook running Prisma generate. One final note. It's considered best practice to instantiate Prisma client outside the handle function of your serverless function. And the reason for this is, in case there's a warm start of the serverless function, it won't need to re-establish a connection to PgBouncer, thereby making your API endpoint faster. The next thing that we're going to do is, now that we know what the repository looks like, we're going to go and create the database in DigitalOcean. And so here I am inside the DigitalOcean console, and what I have is I already have a Postgres database server that is running in a London region, and this is a very important note to make. If you're deploying an app, it's very important to have the app and the database running in the same region and as close to each other as possible, because there's a lot of traffic flowing essentially to handle every request, every client request. The serverless function actually has to go all the way to the database. And so the closer they are, the faster your traffic will be served. And now we will go ahead and create a database. I'll go here into the database tab, and I will add Prisma Vercel example. As a convention, I generally like to name the user with the permissions the same way as the database. And this works for small applications where you probably have just a single user that is accessing the database. And so, okay, great. Now I've created the user and I've created the database. The next thing that I'm going to do is I'm going to create a connection pool. And when I go to this connection pool tab in DigitalOcean, I'll get the ability to start a PgBouncer instance that will handle these connections. That will handle the connections coming into the database. And so the reason that we need this, and this is sort of the main point of this video, is because our database is limited to 22 concurrent connections. And we obviously, in our API, we want to be able to serve a lot more requests. In fact, a database like this can handle at relative ease a much higher load. And so by adding PgBouncer, what we'll be able to set up to 5,000 connections per pool. And so this will really solve the problem that we have with serverless. And so I'm going to go ahead and create a connection pool, and I'm going to call it Prisma Vercel pool. And I will pick the Prisma Vercel example database and also the user. Now this is also important. PgBouncer can run in 3 modes, and for it to work with Prisma, it needs to run in transaction mode. And so it's very important that you have that selected. Now, in terms of the pool size, there is no magic number that fits. If you're only using the database server that you have, the Postgres database server, for only a single database, and that's only going to be serving serverless functions, you can set it up to the maximum pool size. However, in this case, as a rule of thumb, I'm going to just take half of the size. And of course, that can be adjusted along the way based on real metrics, real performance metrics, and so on. So I'll create this pool. And once this pool is created, I'm going to copy the connection string for this. And so here I have it. I'm going to actually change to connection string, and I have the full connection string. And what I'm going to do now is I'm going to go back to my local clone of the repository, and I'm going to actually create that database schema using Prisma. But before I do that, I still need to grant this user that we created permissions on the database, because I don't know if you remember, but when I just created it, I didn't grant it any permission. So right now, if I try to connect as this user, I won't be able to. So I'm going to go back here, and I'm going to take the connection string for the admin user. I'm going to copy that, and then I'm going to open up my terminal. And I'm going to use PgCLI to connect to the database as the admin. And here we are. And if I list the databases, we see that we have this Prisma Vercel example, which we care about. In fact, we're going to connect to it. And so now I'm connected to it, and of course it has no tables yet. And the reason that I'm doing this is so that I can grant permissions to the Prisma Vercel example user. So the first grant command that I'm going to run is grant connect. This will allow the user to connect to this database. The second thing is I want to grant select on all tables in the schema to Prisma Vercel example. And then finally, I want to alter the default privileges in the schema to grant select on tables to Prisma Vercel example. And what this will allow is, this will allow in case we create new tables, like when we create the database schema from the Prisma schema, this will ensure that the Prisma Vercel example user has permissions to these newly created tables. And so I will run this, and then we're pretty much good here. I'm going to go back to DigitalOcean and then copy the connection string to the connection pool. And let's wait for the connection pool page to load. Once we have the connection URL to the PgBouncer connection pool, we can add that to my local clone of the repository. And I'm going to open up VS Code. And so this is the project that we saw on GitHub. And here I had the environment variable file that is inside the Prisma folder. This is the folder that Prisma will automatically try to read the database URL from, at least when running locally. And here I have my test database, but because we're going to migrate the production database, so to say, the one that is on DigitalOcean, I'm going to paste the connection URL here. And then I'm going to run the npx prisma db push command. And what this will do is this will actually create all of the tables in Postgres. So if I connect again to the database, and in this time I'm going to connect to Prisma Vercel example. If I list the tables, indeed we see that we have all of the tables matching the ones that we have in the Prisma schema. So that's that, and I think now we can go ahead and create the app in Vercel. So let's go ahead and move to Vercel. So I'm going to open up the Vercel new project page, and it's already detected that I have this Prisma Vercel deployment example repository. I'm going to click import. I'm going to create it in my account, and this is indeed the correct directory. We'll leave the name as it is, and now comes the important part. So here we have to set up the database URL that will be used by the serverless runtime, by the instances of the serverless functions. And the value to this is pretty much the one that we got here. However, there's one small detail that needs to be added, and that is, we go back here, we paste it, and we need to add the PgBouncer equals true query parameter. And the reason we need to do this is because Prisma operates in a slightly different way so that it maintains compatibility with PgBouncer and that is able to execute all of the queries. And this is why when connecting using Prisma to PgBouncer, it's important to add this PgBouncer query parameter. So we'll go ahead and add this, and then I will go deploy. Great. The project has been successfully deployed. I'll go and open up the dashboard, and here I get the domain for the application, and I can already probably make a request to that because it's ready. Now I'll open up my terminal, and I'm going to make a simple HTTP request to the endpoint. This is the same URL that we had, prisma-vercel-deployment-example. And I'm going to use the /API so that it actually runs one of the serverless functions. And here we get indeed this up is set to true and the region that we returned from that main function. But that of course wasn't a serverless function that was using Prisma. So let's try to maybe create a user. So here I'm making an HTTP post request to the user endpoint, and I'm passing an email and a name. And I expect to get back also an ID. And indeed, this user was created. Now that we've finished deploying our REST API to Vercel and connecting it to the database in PgBouncer and DigitalOcean, we can go ahead and load test the API to see how it performs under high concurrent load. And to do this, we're going to use this open source load testing tool called K6. So let's get started. K6 allows you to define a load testing script using JavaScript. So in the script that I have open here, I'm going to go through it and explain some of the things that are happening. So the first thing to notice is that I have these trends here. And these trends are used to measure the performance of different endpoints in the API. I also have these options where I can define the number of virtual users. This is essentially the number of concurrent requests that will run this load test, and then the duration of the test. Here I define some of the endpoints that will be used, and this default exported function is where the actual load test happens. And so the way it works is that we have these HTTP requests that happen using this HTTP library. And after we make a request, we add a check to make sure that the status was 200, and then we add the amount, the duration of the request to the trend metric that we've created. What this will allow us to do is it will allow us to see how each one of these endpoints performed at the end of the tests. And what we do is we make a call to the feed endpoint, then we make a call to the create user endpoint, and then we make a call to the create post endpoint, another one to the create comment, and then finally to the create like. And there's a little sleep duration between each one of these requests. So let's go to the terminal and run this load test. And I think this is the correct Prisma Vercel deployment example / API. And then let's run this. Now, while this is running, it's worth pointing out that if we didn't have the connection bouncer, there's a very, very good likelihood that the requests would start failing very quickly. And so here we have the result. I will make this a bit smaller so that we can view them all. And what we see is that the status was 200 for all of the requests, so none of the requests failed. And what we see here is we see the results for each of these metrics that we've created for the create comment endpoint, the create like. We see where the 95th percentile, where the 95th percentile lies. We see the median value, the minimum value, and you can see that there's quite a big difference. So from the minimum response time of 120, say, milliseconds to 1.93. And the reason for this is because it takes time when there's a cold start. It takes time for the serverless function to start. Cold starts are a problem that is inherent to serverless platforms. In AWS, this can be solved with a new feature that was recently introduced called provision concurrency, where essentially it allows you to set the number of function instances that are kept warm. This has, of course, an added cost because you're essentially constantly paying for having these functions run. But the advantage is that you don't have the increased latency that you get from these cold starts when new requests come into those functions. In Vercel, however, this is currently not configurable. However, that may change in the future. As this video comes to an end, let's recap what we've done so far. The first thing that we did is we looked at the source code and saw how this REST API was implemented using Prisma in the serverless functions. We then went on to DigitalOcean to create the database and the connection pool, and also set up the permissions for the user that we created. Then we created the database schema using the Prisma DB push command. Finally, we deployed the API to Vercel and connected that with the database on DigitalOcean. And then we ran load tests to make sure that our serverless functions can handle load without exceeding the database connection limit. We hope that you found this video useful. Feel free to leave a comment in the YouTube comments if you have any feedback. Otherwise, you can always find us on Twitter at twitter.com/Prisma. Thank you very much for watching this video.